All right, so last time we met, we looked at the binomial formula, which I told you to write. Please, if you have the binomial formula written down, open it because we are going to be using it right now. So let's look at the first example. This is a flip of a coin 4 times, and X is the number of heads. Remember, there are 4 things to look out for in a binomial formula. 4 things. The first one is the N. The second is the probability of success. The third is the probability of failure. Sorry, the first is the sample size. Let me begin. Let me go back. So the first is the sample size, or the total number of observations or trials. The second is the probability of success, then the probability of failure, then the number of success. The number of success. That's all we want. So here's a question now. A flip of a coin 4 times, and X is the number of heads. What is in this question that proves that this is a binomial question? Or what shows that this is binomial? You can tell us. What clearly shows, what gives you a clue that this is binomial? What's in the question that gives you the clue? Usually, yes, Priscilla.
I'm thinking it's the 4 times.
Is that what?
4 times.
4 coins. 4 times.
So, yes, 4 times.
Okay, 4 times. All right, so the 4 times is not a criteria to determine that this is a binomial. What is it? Christy Amwa.
So I think it have 2 outcomes.
What are they?
The head and the tail.
That's it. So the outcomes are 2 is deductible from what is called the flip of a coin. So you know in your mind that when you flip a coin, once it's about a flip of a coin, then the outcomes are 2. So that's what gives you the knowledge that this is binomial. Please take note. Now, having detected that is binomial and not Poisson or normal distribution, the next thing is, what is n? So who can quickly tell us what's the value of n? Let's not delay with these ones, because we've got a lot to do. What's the value of n? N is 4. What's the value of p? P is 0.5 because it is just 2 outcomes, and they are all equally likely to happen. What is 1 minus p? That's also 0.5. What is x? What is x?
2. 2.
What shows that is 2?
Because the probability of you flipping it twice will be 2.
But you didn't say that flip it twice. So you flip the coin 4 times.
So for the probability of flipping it 4 times is and getting 2 out of it.
No, that's not what it means. Let's see whether someone else gets it. Oh, Salasi, your hand went up and then it came down. Yes, Salasi.
Yeah, so the X will be 4.
What do you mean by 4?
Because the X shows the number of successes in a sample, and then the question is saying flip.
But the sample size is already 4. The number of trials is 4. So how can X be also be 4? I'm only helping you to think. Priscilla.
So I think it will be 1, 2, 3, and 4.
So can I come again?
No. Let Priscilla continue. I think that you've had a very great chance. Yeah, explain what you mean, Priscilla.
So when we throw it out of the 4 flips, we can have just 1 head and the 3 will be tail. And also we can have just 2 heads and the other 2 will be a tail. Can have 3 heads and the other one will be a tail, and can have all 4 to be heads.
You got an idea. You got an idea. Okay. So the sample size is 4, the probability is 0.5, and this is 0.5. The only thing is that you can also throw it and then there will be no head. That's all you missed. Okay. You can throw it and they'll all be tail, there'll be no head. Remember, X is the number of heads. So you can throw it once, okay, and there'll be no head. And you can throw it again 4 times. All of them will be head, or tail, or head, tail. So those options, we looked at this thing the last time, okay? Those options will make us have all of these possibilities. So the first throw, it can be all head. The second throw can be all head. So we have 2 heads. The third throw, it can be all heads. So we have 3 heads. And then the final throw, it can be all heads. Okay. Or maybe that final throw, one of them will be, or it cannot, it may be not a head. It will be a tail. So then it becomes 3. But then you can also do it in such a way that all 4, there was no head at all, which means that the chances of there not, the number of heads could be 0 in all 4 trials or all 4 throws. So that's your hand is up.
There was a mistake.
All right. So having known this, now you have to calculate the probability that X is 0. That's what you got to calculate. The probability that X is 1, the probability that X is 2, the probability that X is 3, the probability that X is 4. These are the possibilities. You got to calculate all of these. So if you take X is 0, you will put the N here, and then you calculate. N will be 4, X will be 0. So this becomes X factorial. And the X factorial will be 0 factorial. I'm just calculating when X is 0. Of course, this question didn't ask you to calculate. Okay. It's only asking you to find the possibilities. And then you can have X here being 0. And you have 0 factorial into bracket 4 minus 0, all factorial. Then you have 0.5 raised to the power 0. 1 minus 0.5, which is 0.5 raised to the power 4 minus 0. 0 factorial is always 1. 4 factorial is this. 4 factorial is equal to 4 times 3 times 2 times 1. That is 4 factorial. 3 factorial will be 3 times 2 times 1. 2 factorial will be 2 times 1. Okay. So you got to know what a factorial stands for. That's it. So you could use that to calculate everything. But yours was to just find the possible outcomes, not the calculation. So that is it. But let's get into the real deal. Okay, a typical exam question related to probability. So what is the probability of 1 success in 5 observations if the probability of success is 0.1? I told you that you should always find the 4 elements in a probability question. 4 elements. So let's start. We need to find N. We need to find P. We need to find 1 minus P. And then we need to find X. So what's the value of N in this one? What's the value of N? from this story, from just this story on the screen? And you know,
It's 5.
it's 5. Okay, there's no question about that. What is the value of P? What is the value of P in this question? Zoe,
1.
it's not 1.
0.9.
Don't guess. What is the value of P? Rita,
0.1.
0.1. What is the value of 1 minus P? That's obvious. What's the value of X? X, and you know,
Is 1.
X is 1. So I want you all to put this into the binomial formula and tell me the answer quickly. If you don't work some of these things with your fingers, you will find yourself wanting, because you got to punch your calculator and use that thing you're punching to help you to always get the right answer. Most of the times, your mind tells you that, oh, I know how to work it. But when you are actually under exam condition, you realize that you don't know how to work it. So please work it and let's get the answer to this very one. Okay. Use this formula for the binomial, calculate it, and let me know your answer. I just need one soul to give me an answer to this. One soul, one person, one person. All right, Gurney.
I had 0.328.
Excellent. Okay, 0.328. That is it. That is down here. I could have shown you the answers very easily and quickly, but what is the use if I don't help you to think, if I don't help you to try, and if I don't help you to do what you can do to prove that you deserve yourself. Okay. So we have been able to calculate binomial. So the chances that out of the 5 observations, given the probability of getting a success is 0.1, the probability of getting 1 out of the 5 is just 33%. Next question. What is the probability?
Sir, I would like to ask a question, please.
Yeah.
Please, can you go back to the answer, please? I know it may sound like, but you know, the 5 into bracket, 0.1 into bracket, and then the 4. I don't understand the 4 that is up there, please. I know it's elementary maths, but if you could explain to
The
me.
4 is 5 minus 1 up here.
But, okay. All right.
And
Okay.
that 5 minus 1 is n minus x in the top.
So the bracket we are adding, isn't it? Or we are multiplying?
We are multiplying.
Okay. All right. Okay. Thank you, sir.
Okay. All right. Oh, another one. What is the probability of getting exactly 2 tails in 3 tosses of a coin? Now, of course, this one is binomial because, again, we are dealing with toss of a coin. That's all. All right. So what is the probability? What is the probability of getting exactly? First thing you got to do is to identify your something. So who can tell me that something and tell me the identification? Who will start? Tell me that first something and then the identification of that something. Christy. Yes, Christy.
Hello, Doc. The sample size, which is 3.
Sample size is 3. Continue. Continue.
And then the P, which is 2.
P cannot be 2. I knew you were a little bit quiet because you were now thinking about how you get a P. Don't worry, somebody will help you. Selassie.
So like she said, the N is 3 and then the P is 0.5
Why is that so?
because it's just 2.
What is just 2?
It's just 2 outcomes,
And what are they?
either a head or a tail.
Exactly. It's your understanding I'm interested in. So that is why it is 0.5. The chances of you getting a head is 0.5. The chances of getting a tail is 0.5. Now, we are left with our X. What is our X? Who can tell us what the X is? Two tails. So that's the X. X is 2. Exactly means equal to. Exactly means equal to. So you're going to do probability of X equal to 2 tails. And then use a binomial formula to find the rest. So that is how you calculate it, okay? You have this 2 tails. You substitute the value just into the same binomial formula. If you do that and you calculate and you work it out well, you are going to find out that the value is 37.5%. So the chances of you getting all 2 tails in 3 tosses is 35%. I mean, you guys can guess clearly. Now, if I throw the first one, you know, I can get a head or tail. Okay. The second one, I can get a head. The third one, I can get a tail. You know, and then, so you can see that if you have to even do a bit of a split, you're getting closer to that percentage. So that is how you find this. That is how you detect the 37.5%. Let's take another one. And as we go, try and note how we are always able to distinguish between binomial and Poisson, or how we were able to prove that this is binomial. Let's take this one. It might not be straightforward. Hisense Ghana produces and sells HD TVs. They are inspected at the end of production process at a quality control station. Out of every batch of HD TVs, 4 are randomly selected and tested for defects. Given that 20% of all batches are defective, what's the probability that each batch of HD TV will contain exactly 2 defective HDs? Now, first thing you got to do is to check whether this is binomial, and if it is, what makes it binomial or not. So let's get it first. What makes this or not a binomial? What makes this a binomial? Green. Jenny.
The outcome will be either a defective HDTV or a non-defective HDTV.
Good. So that is the outcome, defective or not defective, 2 possibilities. Now, having known that, we have to dictate our N. Again, our P, our 1 minus P, our X. So what is the value of N? What is the value of N? Priscilla. Your hand is down.
Yeah, my hand was raised for the first one, not this one. Sorry.
Okay. And you know,
It's 4 because 4 was randomly picked.
good. So X is 4. There's no doubt about that. S is 4, so you put a 4 there. What is P? What's the probability of success? What is the probability of success?
So will that be 20?
It will be 20%.
20%.
And the reason is because the probability of success is neither good or bad here. It is just to indicate how many of them are going to be effective. Okay, so the chances of getting a defective is of a success. And then, of course, the probability of failure will be 0.8, since the probability of success is 0.2. That leaves us with our x. What is x in this question? Rosemary.
X is 2, please.
X is 2. Now, when you are writing the probability, you got to write a probability that x is 2. But please note that the question could have been, what is the probability that each batch of HDTVs will contain less than 2 defective? If it had been less than 2, then the x would be less than 2. But this one is said exactly 2. So that means that x is what? X is equal to. That's what it means. It means that we have an equal to instead of having a 2 less than. So we're going to calculate probability that x is equal to. Substitute them into the binomial formula and work out what is supposed to be. And if you do this nicely, you are going to get something like this. Check it. Check it. Is that clear? Okay. So we've been able to find the probability that x is exactly 2. But let's move on. Let's move on. So the chances of getting exactly 2 defective out of those consignment, whatever the consignment are, if you got a chance of getting defective items at all, the chances are quite slim, just 15%. Now, if 2 or more defective DTVs are found, watch it. If 2 or more are found, now remember that it didn't say or more. What it said was, what it said is exactly 2. Exactly 2. Now, but if 2 or more are found, the whole batch here will be rejected. Because if 2 or more are found to be defective, there's a lot of them being drained. Okay. So that comes to the next question. The manager wants to know the chances of rejecting an entire batch. If in fact the batch has 20 defective items, which is interesting because we already know that the chances are of getting 20 defective items is a probability of success. So that part is not necessary. We already know that. But the manager wants to know the chances of rejecting an entire batch. Now, the chances of rejecting an entire batch is if there are 2 or more defective HDs. So in reality, what the question is asking you is that the manager wants to know the probability of getting 2 or more defective HDT. That's it. That's basically what he wants to know. The probability of getting 2 or more defectives. Now, how do you get that? Please pay attention here. The way you get that is this. Remember that the probability of getting x equal to 2, we have found that. We were told that the samples are how many? Who can remind us? The samples are how many? In this question, what was the sample? 4. Okay.
4.
So the samples are 4. So n is 4. So if we are going to get 2 or more, this time is going to be probability that x is greater or equal to 2. That's what it means, 2 or more. And we know that the samples are only 4. And so this would be the same as saying that I wanted to find the probability that X is 2, added to the probability that X is 3, because remember, it's 2 or more. And then add that to the probability that X is 4, up to the maximum number we already have for the sample. So you're going to find probability of X is 2, X is 3, X is 4. Now, if these samples are 10, then it means that you go all the way to 10, which is too long. So there's an easy way. Now, guys, watch it. Do you know that, what's the total number of probability anyway? What's the total number of probability? It's 1.
1.
So because it's 1, if all of this that we are going to calculate is supposed to be less than 1, so I can go the other way around and do 1 minus something, which will also give me all of this. First of all, it is great. It is 2 or more. This is it. So if I want the opposite of 2 or more, opposite of 2 or more will be what? 0 and 1. That's it. Remember, probability, you don't ignore 0. So this whole thing here can be rewritten as probability that X is greater or equal to 2 is the same as 1 minus the probability that X is less than 1. That's what it means. In other words, if I find probability of 0, probability of 1, I can subtract them from the total probability score, which is 100%. And that will give me what I have below here. That's what will give me. Now, how do we get this one? It's very simple. This is the same as 1 minus, remember, we have to find the probability of X equal to 0. Then we subtract also, is minus for both of them. Probability of X equal to 1. So we find that, you see, now the chances of finding the probabilities are smaller. So here we just find probability of X equal to 0, X equal to 1, add the 2 of them, and subtract both from 1. And that will give us what the question is asking for, which is 2 or more defectives. That's what it means, 2 or more defectives. So that's what we are going to do here. That's what we actually have done here. Okay, so if you understand, we now go to show the work. So as you can see, we've just found the probability of X equals to 2, equal to 3, equal to 4. Then this last one, we are subtracting probability of X is less than 2, which is actually the probability of X is less or equal to 1. So we find that, we substitute, and that will give us 18%. So the chances of getting 2 or more defectives is slim, 18%. Okay, so it means that we are very unlikely to reject the whole batch. The manager is not likely to reject the whole batch. The manager is not likely. And that's it. Okay. Now, the next thing is to find the probability of less than 2 defectives. Less than 2 defectives, that's the same thing that we found. Okay. So that thing that we calculated and we subtracted, which is this part here, that's what the question is now asking you here. Less than 2 defectives. And since you have already calculated it, just bring that here. Then that will give you your final work, which is 81. You can see that 81.92, okay, plus the 18.08. When you add the 2, that should give you 100%. That's what it means. Should give you 100%. Okay, so now that's how you calculate probability. Now, binomial probability, there are two things you should learn about it. I've told you, any random variable that is binomially distributed, any random variable, even if it's not binomially distributed, you can find the mean and then the variance. We've said this many times. So like binomial too, you can find the mean and then the variance. The mean of the binomial is just the sample size multiplied by the probability of success. And the variance is that number also multiplied by the probability of failure. Of course, the standard deviation is just the square root of the variance. You need to know how to calculate this. Very simple. So if you are to go by the example we had, the previous example, what was our sample size? N here was 4. Probability of success was 0.5. Therefore, the mean is 2 for that binomial question. What about the variance? Well, NP is the mean. So this NP here is already 2 multiplied by 0.5, which is the 1 minus the P. And that will give you 1. So what this means is that the variance is 1. And so on the basis of that, you can find the standard deviation, which will be the same. That is how you find the mean and the variance, the mean and the variance. Okay. Now we are ready to go to, the example that I showed you, this is it. Okay, so this one, the example is 5. So you can use that to calculate a couple of them. And you can actually draw the binomial distribution. Okay, all right. Now let's go to the main thing for today. This was a warm-up. All right, so ladies and gentlemen, there's a difference between binomial distribution and Poisson distribution. It's not Poisson, it's Poisson. This Poisson distribution, we normally use it to check, the likelihood of any random variable, which has the possibility of happening over a continuous time interval. The focus is the average of occurrence and not just the occurrence. Take note, write it down bold. The focus is on the average of occurrence instead of the occurrence itself. The average of the occurrence instead of the occurrence. So as an example, we can look at the average of 10, the average weight of 10 people within a specified period, maybe in the year 2001, we specified. So we have limited, put a boundary on when. That's a time. You can look at it based on an area. Okay. For example, if I tell you that the number of goals scored in a football match, you know that the time it takes to complete a football match is how many minutes? It's how many minutes?
90 minutes.
So you know that at the back of your mind, and because you know that it's 90 minutes, if I say that how many goals are scored in the match or the number of goals scored in a match, you should use that knowledge to know that it's not binomial, but it's Poisson. Okay, so we have a couple of examples there. The number of arrivals in a shop in an hour. Okay, so that is the key thing about binomial that I want you to note, even before we start anything. All right, now let's get into the nitty-gritties. This whole thing that we talk about in an hour, within a specified period, within a specified time, within a specified space, all of those things, they are called expected value. Please write the formula for the binomial down. Please write it down. Please write it down. You are not writing. I say write it down. Write it down. Please write it down. Take the pen. Take it. Put it down in your book. Because very soon you'll be using it a lot and you have to know what you have been using. What is the E? E is the base of the natural log. The value for the E is constant. It never changes. It's 2.718. that is E, is the base of the natural log. The lambda, this symbol, the Greek letter lambda, is the expected value or the average number of occurrence. Is the average number of occurrence. And then, of course, X is the probability of success. Sorry, X is the number of success. And then P of X is the probability of success. So you got to know right now, you got to know the binomial formula. Please note, unlike the Poisson, which always has how many elements? 4 things to look out for. N, P, 1 minus P, and X. With a Poisson, unlike the binomial, with a Poisson, it is just the lambda and the X, because the E is always guaranteed. The E is always 2.7182. So you know the E all the time. What you don't know are the lambdas and then the X you gotta find. That is binomial. The key point is that is how binomial is. So let me ask you, let me just give you a scenario. Tell me whether this is, so for example, if the binomial, we know the value of X to be 2 here. Okay. You know the value of X to be 2, you know the value of lambda to be 0.5. Then in order to calculate your binomial, all you got to do is to substitute this into the formula like this, and you get 75.8% as the answer. Okay, get that. All you got to do is to substitute.
Sorry to interrupt, but are we talking about Poisson or binomial?
Sorry, Poisson. Okay, sometimes I miss the two. I'm sorry.
Okay.
But please know that we are talking about Poisson. All right. Let's take a practical guide. Poisson, just like the binomial, remember the binomial, the mean is NP. And then the variance is that NP into bracket 1 minus the P. That is binomial. Poisson, the mean is a lambda, the variance is also the lambda. Take note. The mean is a lambda, which is a mean, and the variance is a lambda, which is a mean, or the expected value. That's it. Of course, the standard deviation is the square root of the variance. So keep in mind that each thing you get a mean, get a standard deviation of the variance. Let's take a practical example, okay, and see whether this is binomial or Poisson. Samsung Ghana gives a 2-year warranty on the phones it makes. From experience, it knows that 0.5% of its phones will be faulty and fail within the warranty period. So statistically, it knows that 0.5%. Now, what's the probability that out of a consignment of 500 phones, none will be faulty? What are the chances that none will be faulty? First, you have to identify the mean, which is in the Poisson. And then second, you have to identify the X. As for the E, which is a natural, the base of the natural log is 2.718. So that's it. So what is the lambda? The lambda is a mean. So how do you find the lambda? Well, look at the question carefully. It says from experience, 0.5% of the phones will be faulty. Now, please note that because of the word faulty, you'll be tempted to think that is binomial. That is faulty and not faulty. But what is in this question that should help you to know that is Poisson and not binomial? What's in this? What is right here that should give you the clue that no. This one is Poisson question.
So is it a 2-year warranty?
It is a 2-year warranty. It's a specified space or time. Okay, so with that in mind, we are now going to calculate the lambda. Okay, based on what we have been given, we have been told that 0.5 of the phones 0.5% of the phones will be faulty. We know the phones. What is the total number of the phones?
500.
500.
Good. So the lambda is simply going to be 0.5%, 0.5 divided by that, multiplied by that consignment. And that will give you 2.5. You can work it and see. So you now have 2.5. Any question? But that is not your question, your answer. Because the question says, what's the probability that out of that, what is the probability out of that number? None will be faulty. That word none will be faulty is referring to the x. So what's the value of x? X is what? 0. So you're going to find the probability that x is equal to 0 using the binomial formula. I want you all to find the probability that x is equal to 0. When you are done, you let me know. Well, if you should work this thing out, then I hope one soul is working. You are going to substitute the values. Yes, Priscilla.
I had 0.082. No, no, if it's correct.
Yeah, that's correct. 0.082. So the chances of you getting 0 defective or 0 faulty phones is just 8.2%, which means that it's not that likely that you'll find a faulty phone. Your chances are just slim. So it's like the manager is telling you that, oh, don't worry, forget it. It's not gonna make any difference. Samuel, sorry.
Okay, Prof, I just want to have a fair idea of how you calculated for the lambda, the mean again. The 0.5 over the 100 times 500.
Yeah, we were told here that 0.5% of their phones, of means multiply, 0.5% of the phones, and we are told that the number of phones is 500. So it's 0.5% of 500. And 0.5
Okay.
of 500 is 2.5. Does it make sense?
Yeah, it does.
All right. So now we go to the next part of that question. And that is, look at the top. What is the mean of the Poisson distribution here? Well, we found that already. The second part says that, what is the probability that out of the consignment, what shows that out of the consignment, you are going to get more than 3 faulty ones? Try it. More than 3 faulty ones. So if you work this thing well, you will notice that you are going to get 8.2 for the first one, and the second one, you're going to get 24.2 because you're looking at more than 3. These are 500 phones. So if you want to do more than 3, you do 3, 4, 5, 6, 7, 8, 9, all the way up to 500. That would be naive. So what you will have to do is to do 1 minus the below the, below more than 3. And anything below more than 3 is 3 or less. So below more than 3 is 3 or less. So 3 or less means that you have to do probability of 0, probability of 1, probability of 2, probability of 3. Get all of those answers and subtract them from 1, and that will give you the more than 3. That's how you calculate it. And that will be 24%. Okay. Now, let's get going, okay, with these things. Again, this is another one. Suppose that the number of customers arriving each hour. The fact that it's each hour means that it is Poisson. That's what it means, each hour. So the number of customers arriving each hour in a local pharmacy is distributed with an expected arrival rate. The word expected arrival rate means you are being given the mean, okay, 20. So in this case, the mean is 20. The fact that they are arriving each hour means that it is Poisson. And yours is to find the probability that exactly 10 customers arrive in an hour. So that word 10 means that we are dealing with the x. So in this case, the lambda is already 20. The x is 10, exactly 10. So we are looking at probability of x equal to 10, not above 10, not below 10, but equals to 10. You substitute to this, you get the answer. Then we talk about at least 5. You see, if you check carefully, the at least 5 here means that, remember the mean is 20. So if you're going to do at least 5, that will be killer. You're going to die because you're going to do 5 all the way to 20. So once again, you use the 1 minus principle. And in this case, you do 1 minus the probability of 0, then minus the probability of 1, minus the probability of 2, all the way up to 4. So those are the opposite of at least 5. And that will give you for each one of these answers. Very good. You should master some of these things. Okay? You should go through and master some of these things. All right. So that is it. If you calculate this, you're going to get this for the probability of 10. Okay, but the probability of 5, I didn't calculate, but I've just given you an idea on how to calculate that. Priscilla.
Yes, sir. My question is on the X factor, the X exclamation mark, that one. If you have a huge number, how will you go by it? Because like 10, for instance, you have to do 10 times 9 times 8 times 7 all the way. So if the mean is very huge, what do you do then?
This one.
No, the down one, the numerator.
The numerator.
Hey, sorry, the denominator, sorry.
10 factorial, that's what you mean.
Yes.
Oh, but the 10 factorial is easy. It's down here, 362.
But then you said it's a multiplication of like 10 times 9 times 8.
Even when you multiply, your calculator has factorial. Your calculator has got a factorial. So you just type 10 and you type factorial.
Oh, okay. Oh, okay.
See,
all right. Thank you.
Yeah. It tells me that most of you are not working. You are not using your calculator to work. You should use your calculator and work and then know what's happening. Okay. So that is how you handle this. Let's go to the last distribution, which is the normal distribution. The normal distribution has got some beautiful things. Okay? It is a continuous probability distribution. The numbers are not decimals. They are not whole numbers like binomial. You see, binomial is a whole number. It's a positive whole number. But then normal is continuous, decimal, so it can be any number. And you can have a continuous distribution and a cumulative continuous distribution. The whole idea of continuity includes decimalism. Just note that. And there are so many things in life that are of continuous nature, which we call them continuous random variable. For example, the thickness of an item is a continuous variable. The thickness can be 3.4, 3.9, you know. The size of a shoe can be 24.6, you know. The time required to complete a task can be 3 hours, 46 minutes. Even the time to run is 9.6 seconds, 9 seconds, 6 milliseconds. Temperature, height, age, weight, money. All of these things are continuous variables. And like binomial and Poisson, there is also a probability density function for a continuous random variable. There is. I'll not bore you with a write-up, okay? But what I'm interested in here is to know how a continuous probability distribution looks like. A continuous probability distribution is like a bell-shaped curve, a normal probability distribution. And it's like a bell-shaped curve that you see here. The binomial is not like that. The binomial is boom, 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 boom. And this one is a smooth density function, which has multiple things under it. What is the essence of it? Now, so many things in life are normally distributed. And so this bell-shaped curve, sometimes it's called a Gaussian distribution, This bell-shaped curve or the Gaussian distribution is a very popular thing because so many things are normally distributed. So how does this work? Well, the whole area under the normal curve is the focus. So when you always learn how to draw the normal curve like this, and you draw the bell shape, the entire area under the normal curve is what we call the probability distribution, or is the probability value. That is the probability value. That is the value of the probability. And the total area is equal to what? 1. Take a note. The total area of the probability distribution is equal to 1. The goal of our exercise today is to find out portions of the area. Listen carefully. The goal is to find the portions of the area. So as you can see in the picture, there is a portion of the area. But before you can find a portion of the area, you need to know the parts of the probability distribution. The center is always the mean. Take note. The center here is the mean. The center is always the mean. And listen to this. Any movement is from the center to the right or from the center to the left. Take note. Any movement is from the center to the right and the center to the left. Now, the whole area is how many percent? Who can tell us? The whole area is how many percent?
So I'm guessing 100%.
It's 100%. Half of the area is how many percent?
50%.
It's 50%. So if I tell you, watch it carefully, okay, because I'm going to show you something very interesting here. If I tell you that this red shaded area, what you see, A to B, that red shaded area, I want to know it. But I know that the white area here, the white area is 25%. I know that. Then it means that the red area is how many percent? Salas.
25.
And then this whole white area is how many percent?
50.
It's 50%. Keep that in mind. This is the whole essence. This is the whole essence. If you get this, we are going to go. And we are going to go so fast. Okay? Because this is the main thing once you get that. Let's take a couple of examples to get a picture. The mean, the median, the mode, they are equal at the center. They are equal at the center. We'll be using mu to represent the mean, but they are equal. How do you find the area? Well, we can find the area if we know a random variable. Please, when I say a random variable, it's any variable that is continuous. It could be the age of people. It could be the size of something. It could be the weight of something, the height of something. That's what I mean by a random variable. If I give you a random variable, the random variable is represented by x. The goal is to use that random variable and find the probability. The pathway to move from the x, the random variable, until you get a probability, which we know is 100, you need something to help you to be able to cross from x to p. You need something to be able to help you to move from the random variable towards the probability of that random variable. And that is a very powerful thing in normal distribution. That is what we, first of all, the shape of the distribution is left to the center, the mean. And then the deviation from the center is the standard deviation. But we know that the normal distribution means that that item is normally distributed. We know that. So that x variable, that random variable x here, we know that it is normally distributed with a mean mu and a variance sigma squared. We know that. We know that. That's why it's called normal distributed. That's why it's called, that thing is normally distributed in the first place. Now, the question now is that what is that thing that will help us to be able to move from that random variable to be able to get to the probability? Well, the normal probability density function is on your screen here. I won't bore you with that. You will later learn it in your life, when you have started the proper courses. But my interest is what is that thing that can help us to move from X to P? That thing is a very important thing. By the way, when you look on the screen here, if I tell you to find this area here, the area of the blue and the red, if I tell you to find that area, this is how you would have found it. You are supposed to find the distance from the center to A. Remember, I told you that the movement is always from center to the left, and then center to the right. So you need to find the distance or the probability from the center to the A, and then find the probability from the center to the B. And then what do? You add them two probabilities. But that is not the same thing if I wanted the white spaces. If I wanted this white space and this white space, okay? In that case, once you have found from the center to the A, and you have found from the mu, the center to the B, you got to subtract each one of them from what number to be able to get a white space? Who can tell me? Salas?
Say 50.
50 what? 50 what? The area is percentage. So it's percent.
50%.
Yo, Kofiadu. 50%. That's what you need to subtract them from. And that will give you the area that you're looking for. We're going to look at a couple of examples of this. Okay. So let's look at a couple of examples. You are told to find this random variable of the shaded area. Okay, so look at the shaded area. We are going to find it. That entire shaded area, let's say that it actually, to be honest, that entire shaded area is a probability of any random variable. Let me say the probability of X less than B. That's actually what it is. The B is a number. A is a number. B is a number. A is a number. I want all the area less than B. How do you get the area? Do you know that we already know one of the numbers already? Which number do we know? Which number do we know of the? You already know. Yes, last. Josephine.
The A.
The A. We already know the A because A is how much? What's the value?
50%.
We know that this area is 50%. So all we need to do is to get this section there. And once you get this section, we add it to the 50%, then we know the entire probability. Watch it. In finding this section, you start from the center and move to the right. And that is how you find that section. And then you add it to the 50%. What about this A? Well, this A is a little bit tricky. We are looking for the probability of the fact that X is less than A. But how do you find it? You can't find it directly because remember the movement is always from the center going here. So what you are rather going to find is the white space I've shaded, I've indicated. So to get the actual X being less than the number, it has to be the 0.5 minus whatever you will find, which is the probability of X being equal to A. That's what you're going to find. You're going to find the probability X being equal to the number A. Then you take that one out of the 5 because you know the whole area here is 5. And once you take it out of the 5, you will know the small cyan color area, which is what you're looking for. That's how you find it. This last one, I've already demonstrated it before. If you want to find this, you find the probability of A. So you find the probability that X is equal to A, which is a red one here, because it's direct. And then you add that to the probability that X is equal to B, because it's also direct. When I say direct, it starts from the center. And then you add the two, and that will give you the red and the blue shaded area. Let's take one example. How do you get to that area? You use something we call the standard normal variable, the standard normal variable. So I told you that once you have this X, which is a random variable, you need something to help you to be able to get to the probability. And that something is called the Z variable, the standard normal variable. It is the one that you have the Z values for it, the one that I've posted, the one that you all have in the PDF, that one. But how do you get it? How do you convert an X variable to a Z variable? It's very simple. The proposed idea have been given to the world, Gaussian distribution has been given to the world with this formula. And the formula says that once you know the random variable, you subtract the mean and divide it by the standard deviation, and that will give you the Z value. Then you can read the Z value from the table, and that will give you the probability or the area. Okay. That will give you the probability or the area. Okay. Now, let's take an example. If income of Kaya use sellers is normally distributed with a mean of 100 and a standard deviation of 50, that's what you got to draw first before you even come to the actual question. So anytime you're giving the thing, draw. And how do you draw? Just sketch something like this. Okay, you draw some horizontal line, you draw a bell-shaped curve, you always indicate the center of the curve. You got to draw this in an exam situation. And you know that the center is always the mean, so you indicate the mu. And then below the mu, you also indicate the standard deviation formula. In this question, what was the value of the mu? What's the value of the mu?
100.
100.
So you write 100, and what's the value of the standard deviation?
50.
You write that down. Now that you've indicated that, you go to the question and look at what the X is asking you for. The X says, what is the probability that if I select a Kayayo at random, closing my eyes, given the fact that the average salary of Kayayo sellers is 100, with that deviation of 50, what is the probability that this Kayayo I selected closing my eye, what shows that guy is making less than $200? See this. What shows? What shows? Well, quickly, that random variable which has been given to you is the 200. That's the X. The mean has been given to you as the 100. The standard deviation has been given to you as that. So you can use the Z formula. What does the Z formula say? Z is equal to X minus mu over the standard deviation. So it will be what minus what? Divided by what? It will be what minus what divided by what? So that's
So it will be 200 minus 100 over 50.
and that is going to give you a value of Z value of what? 2. Always make it 2 decimals. I'll tell you why soon. So instead of writing 2, you write what?
2.00.
Thank you. You write 2.00. Now you have been able to find the Z value. How do you now get the corresponding probability? Now, first of all, let's indicate where the 200 will be on the graph. Will the 200 be on the right or on the left of the 100? The 200, will it be on the right or on the left? Tesla. Tell us.
So to be on the right, but I
On the
have a
right.
question.
Go ahead.
So please, the statement reads, will the income less than, and what's the probability that a Kayo will earn income less than 200? Now, from the other ones, we were taking into consideration the less than, the equal to.
Yeah, we are
and all
now
that.
about to take into consideration. We haven't done.
Because okay, thank
We
you.
haven't done. We are only finding Z and then go and properly do that. Okay. So now we know that the X value will be to the right of the 100. So the X, you indicated there, it will be equal to 200. So that's it. And now the question says less than. We know that it is 200, which is to the right of the 100. Now the less than means that we need to shade one of these areas. We have area A, area B, area C. Which area do you think this question is on about? Which area? Given the question, develop.
Less than 2, that would be area B.
That would be area B. That will not be correct.
Okay.
Rita.
Area C.
A and B.
It will be A and B, correct. Because less than means everything on the left of the 200. And so this is what you will shade. You will now shade this area. Even if you're in an exam situation, you will shade this area to let the reader know that you know exactly the area you are looking for. Now, given this, I'm sure you already know the A part. That's what percent?
50%.
It's 50%. So what do we now need? We need a B. And the B, in the movement of the B, we are going to start from the center, isn't it? Moving towards the 200. So the actual thing that we need to find is this zero section here. That's what we need to find. And we start from the center going right. And that is actually what this number 2, the Z value, has calculated for us here. To be honest, that is the Z value. So the Z value for that is for the 200 is 2. The question we have to still answer though is that how do we convert this to percentage probability terms? This is where you take your table. So please, I want you all to go and take your Z table. Go take your Z table. We are going to find something interesting here. Where is mine? So take your Z table and find this yourself. How you read the table is very important. Okay? How you read the Z table is very, very important. Sometimes if you don't read the Z table well, it can be kakai. I'm trying to show you a Z table. I need some of you to just say something on your page so that I can even pick the one on your page. Anyway. So let me just show you this Z table. Please confirm you can see my screen.
I can see your screen.
Yes, I can see.
So on this is a normal distribution table. The Z is actually read from the left side here. So when you see this is a Z, so you pick the number on this far left column. The number we had was 2.00. Okay, so if it is actually 2.1, you take this one down here. If it is 1.2, you take this one there. But it is 2.00. So first of all, we need to find 2.0. Okay. Have you all seen the 2.0? Have you seen the 2.0?
Yes.
Good.
Yes,
Once you've
please.
taken the 2.0, you come to the top part and add the 0.00 or 0.01, whichever one it is. Okay. Sometimes you can even have one, for example, if you are having 1.42, suppose you are dealing with 1.42, then you have to come and take 1.4 here, and then the 2 will be at the top there. And so the number you are looking for is 0.4222. That's where they meet. If you are dealing with a number, say 1.67, okay, you have to come and read the 1.6 on the far left here. Then it's left with a 7. The 7 is picked at this section here. And then where the two of them will meet, you pick the probability value, which is 0.4525. Basically, that's how you do it. So in our case, what is going to be the Z value? Who can tell me? In our case, what is going to be the Z value? Josephine.
Okay, so the Z value would be 0.4772.
Okay, it's 0.4772. So that is our Z value. So now we've been able to get a Z value. We go back to our analysis. Don't forget, it's 0.4772. So we come to our analysis, okay, and you will notice that this is the area that we're dealing with, okay, and that value is the B part that we drew. Okay, that value is the B part, which is this part here. But we already know this part, which is 0.5. So what do we do to that? With a 0.4772, what do we do? You add them, isn't it? You add them. And so this is how you write the final answer down here. The probability that X is less than 200, or the probability that Z is less than 2 is the same thing. It's going to be that 0.5 plus a 0.4772 that you wrote, and that will give you 97.72%. So we've been able to find the probability that if I pick a Kayayo, the chances of that Kayayo getting less than 200 is 97%. What do you think will be the chances of picking a Kayayo earning above 200? Please remember that when you say above 200, it means that that person can also earn 1 million. What is the chance? If the chance of getting a Kayayo earning below 200 is 97.7%, then the chances of that Kayayo earning above 200 will be how much? Priscilla.
0.0228.
So how many percent?
2.28%.
That's it. Okay, so it's almost 3%. So the chances are quite slim. Okay, and that is how you analyze probability. And that will not be the left side of the 200, but be the right side of the 200. This is how you calculate probability. Of course, there are several ways you can analyze this probability. I just look below. Sometimes you can have between something and something. Sometimes you can have above. Okay. For example, you can be told to find the probability that a Kayayo is earning between 80 and 120. So you have to shade this side rather. 80 is on the left of 100. 120 is on the right of 100. So they're actually telling you to find this shaded area. How do you do it? You have to go and find the corresponding Z value for 120. That means you need to find Z equal to 120 minus the mean, which is 100, divided by the 50. You get the Z value. Then you go and find another Z value for the 80. So that would be Z equals to 80 minus 100 over 50. It doesn't matter whether it's negative or positive, don't worry. You will always get a Z value. So whatever Z value you get here, and whatever Z value you get there, you are going to read them directly, each one from the center, each one from the center. So there's no subtraction. You just add the two of them. When you add the two of them, that will give you the probability that a Kayayo is earning between 80 and 126. So you got to learn some of these things. Some of you can give yourself questions. Yes, Enina.
So the table that you use to check the the Z value? Is it constant? Is it something that you need
It is
to
there are different values, but I will give you the constant one for your purpose.
Okay, all right.
I'll not change this very one. This is the same one you'll be using. Okay. So everything that we have done is here. You can find below, you can find above, you can find anything. Okay, and all of that. Okay. Now let's find another angle. I've given you multiple examples here, so you can check them later. Now, what about if it is rather the opposite? Okay, if it is the opposite, let's say I told you that you can be given the X, and then you have to use the X to find your Z, and then the Z can be read on the table, and you can find your probability. So that's cool. What if now the probability has been given to you, and you have to move backwards to find the X? Well, the nature of the question is in such a way that if you have a Z, and Z is equal to X minus mu, equal to the standard deviation, you can make X the subject, can't you? You can make X the subject. Yeah, by cross multiplying. So when you cross multiply this sigma by the, that is what gives you this. And then you move the minus mu to the left-hand side, becomes plus mu. That is this. And then X will stand alone, which is that. So X has been made a subject from the Z standard normal formula. So we can convert backward, but it depends on the nature of the question. And because you get some of these things, it's important I give you one of them to try. So let's look at this. Suppose the price of Wache is normally distributed with a mean of 8 cedis, standard deviation of 5 cedis. What should the price be? Now remember, the word price here is a random variable. So when I ask you, and by the random variable, I mean the value X. So when I say, what should the price be? I'm asking you, tell me a new X or tell me the X value. Now, the best thing you can do to do something like this is to always draw. What should the price be? What should the price be? Now he's telling you that what should the price be so that only 20% of all prices are below this price. Frederica. What should the price be so that only 20%? Forget about this and try to understand the mean and then the normal distribution. So let's go and draw first. We are told that the mean is how much and the standard deviation is how much. Draw your normal table. Draw. That's the first thing you want to do. So I'll pick the normal table here. I draw a beautiful normal table there. That's the first thing. Second, draw the bell-shaped curve. Good. Third, indicate the mean. In this question, we are told that the mean is 8 cedis. So you just write mu equal to 8 cedis. We also told that the standard deviation is that you always put the standard deviation below the mean, which is 5 cedis. Now listen to the question now. Question says, what should the price be? That word, what should the price be, means he's asking you for X value. But we know that from the left side of this whole normal distribution to the right side is X value. There are several X values there. The center one we know is 8. So we also know that the value 4, will it be above the mean or below the mean? We know the value 4, will it be above or below the mean? Given this, if the price of Wache is 4, do you think the 4 will be above the mean of 8 or below the mean of 8?
Below the mean.
Okay, so it will be below, and 13 will be above, and 17 will be above. Now go back to the question. It says that what should the price be? So we are looking for a price along this horizontal line. But the way we can get a price is this. Only 20% of all prices are below this price. So listen to the word though. Only 20% of all prices are below this price. Listen carefully. Only 20% of all prices are below this price. So watch something here. As you are on this chart, as you are moving from the left to the right, what are you doing to the percentage? What are you doing to the percentage? What are you doing to the percentage? What are you doing to the percentage?
So you are increasing your choices.
You are increasing the percentage.
Yes.
Okay. So it's you are increasing the percentage. So it means that the lower percentages are on the left and the higher percentages are on the right. So 50% is on the left, 60% is above 50%, 70% is above 50%, 80 is above 70, 90 is above 80, and then on until you get to 100. The area from left to right is 100%. And you are told that only 20% of all prices are below this price. So first of all, I need to identify 20%. 20%, will it be to the right of the mean or to the left of the mean? Given that when you're moving from the left to the right, the thing is increasing. Rita. Yes, Rita. All right.
Hello.
So 20%, it will be to the left, okay? You have 20% to the left here, okay? So we know that 20%, but it's not the value I'm looking for, okay? 20% is a probability. That's why it's a percent. So it's a probability. Now, I know that 20% is from 0 to 20% here. The question says, what should the price be so that only 20% of all prices are below? So all prices are below this price. Below. Below means what? Is it to the left or to the right of this 20%? By the way, 20% is this area. This area is a 20% or 0.2. Okay. And he is saying that we want the prices that are below this price. So which area are we looking for per se? Which prices are we looking for? We are looking for prices below this price. Okay. And which prices are below this price? Is this area here? That's what we are looking for. Well, that one is a 20%. So I need this X value. I need this X value so that if I get this X value, the prices will be below. So if this X value is say 6, then I know that below 6, cedis, okay, 20% of the prices are below 6 cedis. That's what I will know. So how do I get that question mark, that X question mark, that X value? Well, you have to use the Z formula. That's it. What's the Z formula? Before you use the Z formula though, check this. We are told that this area here, this green area here is 20%, which means that this area here is what percent? It means that area is what percent? Just
50%.
It's 30%. So we know that this area here is 0.3. That's it. We know it's 0.3. In fact, that is the area we have to read, because remember that we always read from the center going to the left and from the center going to the right when we are dealing with probability. Okay. It is after that we are able to know the 20% which was given to us. So we have to read 0.3. So where is that 0.3 is 30%? Where did we read it? It's in the table. So we need to go and find that 0.3, because that 0.3 is ending here is what we are looking for, the price down here. So we need to find that 0.3 from the table. So we've got to go to the table. Let's go to the table. And we are going to search the entire swimming pool of the table. I'm going to remove this. We're going to search the entire swimming pool of this table. We're going to comb the entire table and look for a number or two numbers or numbers closest to 0.3. Let's start. Which number or numbers is closest to 0.3? By the way, the number is always towards the highest of 2 point something and the lowest of 0.3 something. That's how it is normally. Have you found a number or numbers closest to 0.3? 0.3000000, or which number have we found closest to 0.3? Very, very close to 0.3. Which number? Who has found a number? So watch here. If you check carefully here, you will find a number. That's it. One of these is a number. One of these two is a number. Which one is it? Okay, this one here. This one here, or that one here. Which one is the closest one to 0.3? And you have to think before you know the closest one to 0.3. No, wait. Yes, hang on.
So, well, is it 2.999?
It's 0.29. Okay. So now that you know that it's 0.2995, and that is truly the closest to 0.3. Please note, most of the time, the ones closest to the number are the ones that are the ones you will not even think about. So you just have to take the number, subtract it from each of these two numbers, and the one that will give you the lowest absolute value is the one closest to 0.3. So we got this one, 0.2995. Now, how do you get the z value? This is the probability, by the way. How do you get the z value? To get the z value, all you have to do is to move left forward. You come and move from here to there. This is the left first part, and then go upward to get the second part. Therefore, the probability, the z value for this is what? Is this 0.8 and then 0.04. So you are talking about 0.84. 0.84. If I tell you to go and read 0.84, you will see that you arrive at the same 0.299. Okay, good. Now you got it. We got a z value. So we can now substitute into our analysis and find the x. So this is the formula. It was z equal to x minus mu all over sigma. But please note, this area we are looking for, is it to the left of the mean? Everything we have been looking for so far, is it to the left of the mean or to the right of the mean? It's to the left of the mean. Anytime whatever you're looking for is to the left of the mean, give the z value a minus. This is in the slides. Anytime, give the z value a minus. If the number you're looking for is to the right of the mean, give the z value a plus. In our case, it is 0.84, but it is to the left of the mean. So I'm going to replace it here. It will be minus 0.8 equal to x. Remember, x is what we are looking for. The mean is 8. The standard deviation is 5. You cross multiply and find your answer. Okay, and you will find that when you cross multiply and you find the answer, you're going to find this sort of value. You'll be able to identify a clear situation that you need. You're going to get 3.80, which is actually to the left of the mean of 8. So our price here is 3.8. What does that mean? It means that if the price of wache is actually 8 cedis, the average price is 8 cedis, and the standard deviation is 5, then 20% of the prices below this 3 cedis, 80 pesos. 20% of the prices below this 3.8 cedis, okay, or let's put it this way. It means that prices below 3.8 cedis are 20%. Okay, 20% of all the prices are below 3.8 cedis. That's what it means. It means 20% of the prices are below 3.8 cedis. In other words, even though on average, When you go and buy the watch, people are buying an average of 8 cedis, 8 cedis, 8 cedis. Okay, 20% of these people are buying watch below 3.8 cedis. That's what I mean. And that is the beautiful thing of this analysis. So 20% of the values from the distribution with a mean blah, blah, blah are less than 3.5. Now, you need to be able to think about the situation where the thing is above, because you could have that. So when it is above, suppose you have something like this and it's above. Yes, someone.
Prof, I just want to know why it's negative 0.84.
Because when you look at the mean was 8. And whatever we were looking for was to the left of the mean. Do you remember? We're telling everything to the left.
Yeah.
That's why it's negative. That's why it's negative. If whatever we are doing is to the right of the mean, it will be positive. Let me give you an example. Suppose I tell you that I want a certain price. What is the probability that you say that I want a price? I don't know the price, but can you tell me the price if we know that 90% of the prices are below this price? If I tell you that I want a certain price, but I don't know the price, but I know that 90% of the prices are below this price. Now, 90%, remember the whole of this movement to the right is 100%. So 90% will be somewhere here. That's what it means. 90% will be somewhere here. So this whole area here be 90%, which means that, and we already know that this area here is half of that 100. So out of that 90%, 50% is here. Okay, which means that this part here is how many percent? That 40. Shaded part is 40%. And so it means that we are going to concentrate on 40% because now the probability is 40%. So we are going to take this 40%, dump it into the swimming pool, and search for two numbers closest to 0.4. And I'm sure it's going to be something like 0.3996 or something. So once you get that number, you trace it up and down. Let's go to the table and look for 0.4. Okay. Let's look for a number closest to 0.4. You see, this is 0.43. So 0.4 is somewhere here. Okay, there you go. You see these two? Yeah. That's 0.4. Let me use a different color to show you. So between this and that, between this one and this. So 0.4 is actually 0.3997 because 0.3997 is closer to 0.4 than 0.4015. I'm sure you all know that. Okay. So now that we know that it's 0.3997, you climb up. Okay. That is 0.08. And then you go leftward. Okay. Go leftward. That is 1.2. So it means that we are going to get 1.28. That is the value. Because this area is to the right of the mean, you don't do minus. So when you have your z, and you're writing your z will be equal to x, which you don't know, and then minus the mu over the sigma. And in this case, the z will be the one you just found here, which is 1.28, equals to the x you don't know, minus the 8 divided by the 5. So when you cross multiply, I just want you to know that the value will be above the mean. So that's what I'm calculating for you to see. So if you take your 1.28, multiply that one by 5, that will give you 6.4. Okay. So when you bring this 8 here, sorry, 6.4. When you bring the 8 there, it's going to be 6.4 plus 8, which will give you 14.4. Therefore, the x you are looking for, which, of which 90% of the prices are below, is 14.4 cedis. I did not do minus because what I was looking for was to the right of the mean. So that's it. I hope you get it.
Yes, Prof.
All right. So that is how you are able to find this. So next time we're going to continue and look at hypothesis testing. Okay. So try and familiarize yourself with some of this in the document so that you'll be able to know how to execute all of this. Ladies and gentlemen, that brings us to the end of the entire Kabuda. Any question, please?